Sir Thomas Brisbane Parramatta Observatory Revisited, 1821 to 1825. It will be a double act by Mark Rigby, the former curator of the Sir Thomas Brisbane Planetarium, and Tom Harradine, an amateur astronomer who has been researching Brisbane and its observatory. Over to you, Mark and Tom.
Thank you, Nick. And as you said, Sir Thomas Brisbane's Parramatta Observatory Revisited, and ours will be in two parts. I'll be dealing with Sir Thomas Brisbane and a little bit of background, since a lot of you may not know much about him. And Tom has done a lot of research on Parramatta Observatory. First of all, we'll talk a little bit about Sir Thomas in terms of he was born near Largs, just on the outskirts in Scotland, in 1773. And if no one knows where Largs is, it's to the west of Glasgow on the coast. He was an officer in the British Army for most of his life until he passed away in 1860, and very distinguished service in the Peninsular War. And he decided to study navigation and nautical astronomy after an incident in the West Indies in 1895. The ship that he was on got separated from a fleet, and the crew on board, unfortunately, wasn't the best at navigation. So they were nearly shipwrecked. Fortunately, Sir Thomas, who wasn't part of the crew or the captain, saved the day, so to speak. Later on, he decided to build an observatory at his estate, and started that in 1805 and completed it in 1808, and it was fully instrumented by 1811. He really got the idea of wanting to map the southern sky. So when he eventually came to the colony of New South Wales in 1821, he had a term of 4 years. In fact, he left his role as governor of the colony on December 1st of 1825. So in 12 days' time, we celebrate 200 years since Sir Thomas finished his tenure as governor. And while here, he established his observatory at Parramatta, and Tom is going to tell us much more about that with visualizations as well. On his return to Scotland, Sir Thomas built a third observatory on his wife's estate on the other side of Scotland at Mackirston. And he received the gold medal of the Royal Astronomical Society for his Parramatta Observatory work, and he became president in the early 1830s of the Royal Society of Edinburgh. The estate itself is on the outskirts of Largs, and if you look at this view I took in 2011, Largs itself is in the distance just to the left of the tree, and Sir Thomas has set up 3 meridian markers on a hill in Largs itself, and he could use those markers to align the instruments in his observatory. During that visit in 2011, it was very hard to see the observatory, very much overgrown. In fact, trees coming up within the walls of the observatory. The roof had long collapsed. But in the years since then, the site has been cleared. So on a visit in 2018, it was much easier to get a feel for it. The site had been mapped. And the Brisbane Observatory Trust, which they asked me to become the Vice President honorary, continues to try and raise funds, and it has done so, but it needs a lot more funds to do preservation, restoration. But also one of the goals is to try and educate people in Largs, as well as in Australia, about the role of Sir Thomas Brisbane. And the Olympic Games in Brisbane in 2032 provides a possible opportunity for some links with Largs at that time. The naming of Sir Thomas Brisbane features, so to speak, with an astronomical bent, takes 3 forms in terms of a lunar crater, a planetarium, and an asteroid or minor planet. The crater Brisbane was named in 1935 by the International Astronomical Union, and it's actually quite a substantial crater, 44-kilometre diameter, bigger than, say, crater Kepler on the Moon, which is a fairly prominent one with lunar rays. But in terms of Brisbane, it's virtually on a limb, out on a limb. It's on the eastern limb as seen from Earth. But as I said, quite a substantial sized crater. The planetarium has a long history, first proposed the year I was born, actually, in 1954 by a group of businessmen. who contacted Zeiss about projectors, but it didn't go anywhere. So the momentum built up in the 60s with the Astronomical Society of Queensland. I was just a junior member in the 60s, and the Queensland Museum Society, both lobbying for a planetarium to different levels of government from federal down. And finally, they found a supporter in the longest serving Lord Mayor of Brisbane, Clem Jones, who in his early career as a surveyor had done some astronomy, and he showed an interest in the idea of a planetarium. John O'Hagan, John was president of the Queensland Museum Society, and he was the one that suggested to Clem that the planetarium be named for Sir Thomas Brisbane, who is often considered the founder of organised science in Australia. And although Clem wasn't Lord Mayor at the time, the planetarium opened in 1978. I retired from the planetarium after 36 years, 4 years ago. Minor Planet Brisbane, they came about when I approached Rob McNaught at Siding Spring Observatory in 2006 and said, Rob, there's no asteroid Brisbane. And Rob was surprised as well because he was born about 20 kilometres from Largs, and he was actually born on the same day of the year that Sir Thomas passed away. So he was keen, and in 2009 we decided to move on it and selected one of his minor planets he'd discovered in the bicentennial year of Australia. And the asteroid was named in October of 2009, and Rob asked me to do the citation for that. It sort of honours the city and Sir Thomas Brisbane in that citation. And as luck has it, asteroid Brisbane is making its closest approach to Earth this weekend. So it's not on a collision course for us, fortunately. I've tried to assure people that in 2009, but don't get worried about this visual. But this is just an impression of what Brisbane would look like, now thought to be 3 kilometre diameter above the CBD of Brisbane. But surprisingly, if Brisbane hit the moon, it would produce a crater about the size of the 44 kilometre diameter crater Brisbane. We were honoured to have Seymour Munro visit us, a senior living descendant of Sir Thomas, visited 2011 with one of his sons, Robert, and they were really pleased to tour the planetarium, look at some of the materials we had at that time to do with Sir Thomas. One item of particular interest was the catalogue of stars based on the observations at Parramatta, and this particular volume was inscribed by Sir Thomas to his oldest child, Isabella, and that is currently in the collection of the Museum of Brisbane. Now, at this point, I'm going to throw to Tom, and Tom has done a remarkable amount of work on Parramatta Observatory. So over to you, Tom.
Okay, thank you, Mark. And my name is Tom Harradine. I'm an independent researcher and amateur astronomer. And in this part of the presentation, as Mark has introduced Sir Thomas Brisbane, we're going to have a look at the Parramatta Observatory under Sir Thomas Brisbane. And we'll be revisiting the Parramatta Observatory between 1821 and 1825. We will do this by taking a brief virtual tour of a 3D reconstruction of the observatory, and we'll have a look at a typical day in the life of its operations. The depictions and descriptions in this portion of the presentation draw upon existing research as well as my own research in progress, which includes the examination of archival primary sources and site visits in both Australia and the UK, the examination of existing instruments, and a detailed examination and analysis of original observational logs. As part of my research, I've so far transcribed a significant portion of the original Parramatta observation logs, as well as the entirety of the Brisbane Parramatta catalogue of 7,385 stars. And at the end of my presentation, I'll demonstrate a couple of visualizations from the data. That image you see here is a time-lapse photo I took a couple of years ago at Parramatta Observatory at night. And the two piers you see supported a transit instrument which is aligned to the south or north-south meridians. We can see it aligned to the south celestial pole. So even in this image, we can see an indelible link of the remaining structure of the Parramatta Observatory and its actual purpose. Parramatta Observatory was Australia's first substantial dedicated astronomical observatory and operated between 1822 and 1847, after which it was demolished. The only physical remains of the building today are two sandstone piers on the original site, located in Parramatta Park, about 24 kilometres inland from Sydney. Initially a private observatory owned by Sir Thomas Brisbane, the Parramatta Observatory became government-owned under the then New South Wales Executive Council after Brisbane left the colony in December 1825. Some of the instruments from the Parramatta Observatory were in fact used in the Sydney Observatory when it was first established in 1858. All of the instruments and clocks you will see modelled in this presentation are preserved in various forms of completeness as an important part of the Sydney Powerhouse Museum's collection. The observatory stood about 180 metres west of the old Government House in Parramatta Park, in the grounds of the former Governor's domain on the land of the Parramatta people of the Darug Nation. And in this image here, I've got an overlay of Google Earth. We could see a model of the Parramatta Observatory, about 180 metres up from Government House. And those that yellow and red line are the meridian lines of the observatory, where meridian markers were placed within the confines of the Governor's domain. And don't worry about that duck in the corner there. I think that's a visit from a large inflatable duck in 2014. So you can look that up if you like. That just so happened to be caught on the image. Brisbane's purpose for establishing an observatory in New South Wales was to take advantage of its location in the Southern Hemisphere, being diametrically opposite to European observatories and half a world away from the British government's yet-to-be-built Southern Observatory at the Cape of Good Hope, at nearly the same southern latitude. Parramatta Observatory could therefore make observations that were unachievable from and also complementary to those locations. Its main aims were to catalogue southern stars in greater detail than before, to measure Earth's tilt by observing the sun's altitude around the solstices, to make pendulum-based gravimetric readings to refine Earth's ellipsoidal shape, and to take positional measurements of the moon and the planets to improve navigation and knowledge of the solar system paradox, and to observe transit phenomena not visible from the northern hemisphere, such as the 1822 transit of Mercury, the solar and lunar eclipses, and comets. And so we can see that Brisbane's aims wasn't far from being just sometimes being characterised as just an amateur. He was quite serious about meeting these aims in setting up the observatory. In addition to supplying a complete astronomical library, as well as the equipment needed for a modern, well-equipped observatory, Brisbane brought with him to New South Wales two assistants. The ages I have here on the screen are when they arrived in Australia on the 7th of November 1821, after about a 6-month journey. Karl Rumke was a published astronomer and was responsible for implementing the observing program and for the data reduction of the observatory's raw results for publication. James Dunlop was a technically skilled assistant from Dalry, near Largs, who was tasked with maintaining the observatory's instruments and clocks, as well as performing routine observations. Brisbane, for his part, as owner and employer, also contributed to the observations. And unfortunately, after a dispute in June 1823, just over a year after the observatory opened, Rumke left the observatory, and so therefore leaving Brisbane without his principal astronomer. So it was down to Dunlop to manage most of the observations under Brisbane's tutelage and guidance. And Brisbane himself made a substantial amount of observations as well. Construction of the observatory began soon after Brisbane was sworn in as governor on the 1st of December 1821. The building was largely made of wood and was essentially a shell built around sandstone foundations for masonry piers which supported the clocks and instruments. No part of the frame, walls or floor would be in contact with these piers or the foundation, so as to avoid movement and vibrations interfering with the observations. The observatory roof featured two longitudinal openings aligned north-south directly above the two meridian instruments inside. The north and south dome were covered in canvas. The openings of the roof and the domes were, or the coverings for those openings were contemporarily described as slides and were possibly also made of canvas. Parramatta Observatory was completed and ready for use by the second week of March 1822. And the building measured about 8 metres wide and about 11 metres long. The interior featured 2 rooms separated by a central partition. The design, dimension and layout of Parramatta Observatory closely resembled Brisbane's first observatory in Largs, of which we saw the ruins in Mark's presentation. And the observatory in Largs could be considered as the prototype for Parramatta, even though it was more substantially built of stone and in a much better condition, relatively so than the Parramatta Observatory, which only has those 2 piers standing. So now let's take a virtual tour of the Parramatta Observatory as it was during Brisbane's time. So after a short walk up from Government House, we arrive in the building's east side, and passing through its only door, we enter the north room of the observatory, which measured roughly 8 by 3.5 metres. Near the western wall stand 3 masonry piers. Mounted on the central pier is a Breguet clock, which ran at local mean time and was used to record the timing of occultations, transits and eclipses. The 2 outer piers supported a stone slab upon which was occasionally mounted a Cater's pendulum on loan from the Board of Longitude. Dunlop and Brisbane used it to measure the local gravitation acceleration by comparing the pendulum's motion against the Breguet clock's pendulum positioned directly behind it. The Cater pendulum presumably returned with Brisbane to Britain when he left the colony. And now we're stepping up into the North Dome, which is about 3 metres diameter. We could see it housed a Reichenbach repeating circle fitted with a pair of 2-foot-long, 1.5-inch aperture telescopes. And this instrument could measure large angular distances between celestial objects. Brisbane and Rumke used the Reichenbach to record the sun's zenithal distance in the days preceding and during and after the solstices twice a year. These observations were later used to calculate the Earth's axial tilt. Okay, we'll now head down into the south room, and you see that a couple of bookcases there indicating the amount of books and tables that Brisbane brought with him out to Australia. Okay, so the south room measured about 4.5 by 8 metres and housed the observatory's 2 meridian instruments, and we'll return to this right after exploring the southern dome. So again, 3 metres across, and in the South Dome we see an equatorial refractor telescope by Banks. It's 44 inches long, 3.25 inch aperture. It was used for off-meridian work such as tracking comets and observing eclipses. A wire micrometer at the eyepiece enabled precision angular measurements to be made between objects in the field of view. Before Rumke left the observatory, he used his telescope to recover and track comet Encke in June 1822, to track a comet discovered later that year by Dunlop, and to observe the transit of Mercury in November 1822. And it's worth pointing out that for that transit of Mercury, Brisbane had brought his own personal instruments with him to Sydney, and also timed the transit of Mercury so they could have 2 positions to measure it from. Eclipses of the sun and moon were also observed using this instrument. Dunlop later used the same instrument for double star measurements. Okay, we'll go head down now into the southern room, and mounted on an angled masonry pier adjacent to the eastern wall, we see the beating heart of the Parramatta Observatory, a sidereal regulator by Halley. The Halley clock kept sidereal time and was vital for both observatory timekeeping and for timing measurements with the other instruments. Given that sidereal time was based on the positions of the stars, the clock's rate was calibrated by the daily observation of bright stars of well-catalogued positions, known as clock stars. Observations of these standard clock stars were often made in broad daylight. And nearby the Halley clock stood the mural circle, located directly under the eastern meridian roof opening. The mural circle was used to measure an object's south polar distance, from which the declination, or the star's celestial latitude, could be determined. This is one of the main instruments used in measuring the positions of the stars for the catalogue. The instrument comprised a circular brass frame carrying a 2-foot telescope, which only had about 2 inches aperture, and was fixed to a conical axis mounted to a cement mounting block. Observations using this mural circle were made by Rumke and Dunlop. It's worth pointing out that this mural circle has quite a heritage, being likely the prototype used by Troughton to demonstrate to the Greenwich Observatory for the design, this new design of a mural circle. And Brisbane had purchased this item and had it mounted in Largs. So it's currently in the Powerhouse Museum in Sydney, but it does provide a direct line back to its British roots. And to make an observation, the telescope was tilted up to the star or moon or planet or sun, and once the Earth's rotation carried that celestial object into view, and once it was crossed the crosshairs in the field of view, the circle was clamped off and readings were taken from 4 microscopes that measured the divided scale on the circle's rim. Averaging the 4 microscope readings gave the apparent south polar distance to a 1/10 of an arcsecond. Heading over to the other main instrument of the observatory. This is the transit instrument by Troughton, and it lies beneath the western meridian opening. It's the largest instrument in Brisbane's observatory, being a 5.5-foot transit telescope with a 3 3/4 inch aperture, suspended between 2 sandstone piers. Now, one of these piers survives today at the Parramatta Observatory site, and the other one, the taller pier on the current site, comes from a transit circle installed in 1835. Aligned north-south, the transit instrument could swing freely along the meridian to measure the apparent celestial longitude, or right ascension, of an object. And it was used by both Rumke and Brisbane, with no record of Dunlop having ever used it, although Dunlop did use a transit instrument at the Mercurston Observatory under Brisbane. Okay, we'll just have a look at the field of view. The field of view of the transit telescope had 5 vertical wires evenly spaced and 1 horizontal wire. At night time, these wires were illuminated by a lamp. As the Earth rotated, celestial objects drifted steadily across the field, crossing each wire in turn. To record a transit, the observer noted the time to the nearest second on the Halley clock and kept a mental count, listening to the clock's ticks. And as the object came into view and crossed each wire, the observer would or could record the timing of the wire crossing to the nearest 1/10 of a second. Averaging the total of the 5 wire times would give the object's apparent transit time across the meridian. This method was called the eye and ear method, and required intense concentration and a very quiet work environment so as the ticking could be heard. This manual method was soon after superseded by the use of electronic chronographs, and then by astrometric photography in later Australian observatories. Okay, so let's briefly touch on a typical day in the life of the observatory. I've chosen Thursday, the 19th of March, 1824. And so these are from the original records of the Parramatta Observatory. By this date, the observatory had now been operating for 3 years, with Rumke having been absent for 2 of those. So it was left to Dunlop to work the mural circle and Brisbane the transit instrument when he could. On that Thursday morning, Dunlop would have walked from his home in Parramatta about 10 minutes away and arrived in time to open up the observatory to have everything ready before Brisbane later arrived just before the first observation of the day. As I said, Brisbane worked at Government House, so it was quite convenient for him to come and go as he pleased. The observation logs for the day indicate the first observation was the planet Mercury, which crossed the meridian at 10:55, followed by 7 minutes later by the first clock star of the day, Fomalhaut, situated almost directly overhead and in broad daylight. After those observations, Brisbane didn't need to come back until midday. So he would have returned back to Government House to do some work. Just after midday, the two Scotsmen measured the sun's limbs. The mural circle could only measure one limb, lower or upper limb at a time of an extended object. And the transit telescope for an extended object such as the sun, the moon, or a large planet would record both the first and second limb crossing times. And the average would get the time of the object's transit. And while Dunlop, so Brisbane went home, and Dunlop in that meantime continued with two mural observations of Aldebaran and Achenar, again in full daylight. Both men resumed after 5 p.m. to record Capella and Rigel. Capella would have been a challenging object, culminating at only 10 degrees above the northern horizon from Parramatta's latitude and in broad daylight. Brisbane's observation logs indicated that he had only 19 seconds between Capella crossing the fifth wire and Rigel crossing the first, leaving that short period of time to orientate the telescope in enough time to get himself settled with the clock count ready to time Rigel. This instance, recorded in the logs, demonstrates the skill of Brisbane as a practical astronomer. Evening was reserved for the observation of stars for the catalogue. Brisbane's evening observation sessions were generally shorter than Dunlop's, as Brisbane likely had dinner first before heading out to the observatory. On this night, Brisbane logged 19 southern stars between about 7:26 and 8:43. Dunlop commenced his session earlier at 6:33, recording 51 stars by 10:45. Dunlop would have closed up for the night after that, leaving the slates that they recorded the observations on for transcription into the logbooks the following morning. He would have walked past the dormant Government House and then made his way back home in the dark to Parramatta. Both men averaged about one observation every 4 minutes, so they were quite busy. After Brisbane left the colony, exactly 4 years after commencing his term as Governor of New South Wales, Dunlop continued to make mural circle observations under his own steam until March 1826. Between 1822 and 1826, over 36,000 mural instrument observations were made at Parramatta Observatory, and almost 9,000 observations were made with the transit instrument. These observations were used by Greenwich astronomer William Richardson to later compute and compile the Brisbane Parramatta catalogue of 7,385 stars, published in 1835. And we can see a typical page here with the numbers, names of stars when known. And again, I've transcribed the entirety of this catalogue, which has enabled me to demonstrate a bit of a visualization of where, for example, in this screen, the mural circle instrument was pointed. And so we can see a very large with the south at the left. We can see that it was the southern stars almost up to just past the zenith. And again, the transcription of the catalogue allowed for star maps to be made. I have created an entire star map of the catalogue. Here's a small part of it within the Southern Cross region where we can see each of the stars with individual numbers.
Sorry, Tom.
That's fine. That's brought me to the end. So
2 minutes to go.
Yeah, that's good. Thank you. Almost there. Thanks for that. The visualizations shown today illustrate only a small part of what can be achieved through detailed examination and analysis of primary sources and existing literature. Many stories contained within the observations, data and surviving instruments and archaeological traces remain untold. And this presentation has only provided a brief glimpse of the scope of the research done so far and the potential for examining historical records to bring the Parramatta Observatory to life once more. And Mike's, the research I've done is quite extensive. Just a few acknowledgements there to the various archival and library resources in Australia and UK. And also just a shout out to some individuals, Dr. Andrew Jacobs, Sydney Powers Museum, for giving me access to the original instruments, and Christopher Levins and Verena Maldron, and Largs residents David Ennis, Colin and Valerie Campbell for their hospitality and local knowledge. So with that, I'd like to thank everyone on behalf of Mark and I, and thank you very much.
Thank you very much, Tom, and Mark as well. fascinating talk, and I really enjoyed that 3D reconstruction and seeing the objects which are on display or used to be on display at Sydney Observatory.